This is the continuation of the above question. This is the third question. So if we pass B through the sigmoid activation function, input X is a matrix of 4 cross 4, right, is passed through a kernel or filter K, and the output of this passing through kernel, so kernel given is 3 cross 3 matrix, right, 3 cross 3, that is 1 0 1 0 0 1 1 0 1, and we produce a matrix. The output of the X input array is passing through a kernel. The resultant output is matrix A of size 2 cross 2, and the values are minus 1 1 2 and 5. We already solved in the previous question, right? This one, this is the X filter and the output matrix A. After matrix A passing through average pooling, that is average pooling. After this is passing through a matrix average pooling, the resultant matrix is, so it's not a matrix, is a B, and the value is 1.75. After the average pooling, that is average of all these 4 numbers, minus 1 1 2 and 5. B through the sigmoid or logistic function with weight equal to 1 and no bias. So after the output B is, that is B output is passed through a sigmoid activation function with weight equals to 1 and bias equals to 0. The output of the sigmoid function is y hat, and L is the some loss function that depends on y, given that dou L by dou y hat equals to minus y. So y hat depends on the loss dou L by dou y hat equals to minus 1. Of very important, they are asking to find the dou L by dou k 0 0, and k 0 0 is the element of the k at index 0 0. So please remember, in this question k 0 0, k means the filter, k 0 0, generally k1 k11 k12 k13, like that we consider, but here they mention the index starts at 0 0, that is 0 comma 0. So that is k 0 0 k 01 k 02, that is 1 0 1 values. So for this question we have to change the filter size is also starting index 0 0 and the input X array of elements X 0 0. Okay, it's mentioned in the question. Note that use the 0 indexing here. So they are asking to find the dou L by, that is differentiation of loss with respect to filter k 0 0. This question is related to backpropagation. This question is related to the backpropagation. So from this here, so dou L by dou y hat. So what they are asking, dou L by dou k 0, right? So dou L by dou k 0 equals to dou L by, first start with differentiation with y hat output, dou L by dou y hat times, here y hat goes up, that is dou y hat divided by dou b, right? After y hat output, how y hat is coming, the sigmoid operation, after y hat the b is there, that is average pooling output, dou b. After this b goes here, that is dou b by, after this we are coming to, after average pooling here, right, the kernel k, so but they are asking k has 6 elements, so with k 0 0, that is dou k 0 0, right, This is the back propagation function. So in the question they given dou L by dou y hat equals to -1. Its value is -1, and we want to find this and this value, and dou y hat by dou b, dou y hat by dou b. So that is dou y hat by dou b. That is, in back propagation we go backward, so the differentiation of the sigmoid function. So derivative y hat, so y hat equals to sigmoid of b value, right? B value is 1.75, sigmoid of b, that is y hat equals to sigmoid of b value is 1.75. Sigmoid function 1 by 1 plus e power minus z, right? Minus z, that is 1 by 1 plus e power minus 1.75, and its value is 1 by 1 plus 0.1737. So that is, its value is y hat equals to 0.8521. Okay, this is the y hat value. So derivative of sigma of z, that is sigma dash of z. Dash represents the partial derivative, first order derivative, right? So the sigmoid derivation is sigma of z, z times 1 minus sigma of z. So sigma of z is we already calculated, right? So this value z equals to 1.75. Here sigmoid of 1.75, that is sigma of 1.75, 1 minus sigma of 0.8521 minus 1 minus 0.8521. So its value is 0.1261. So this value is 0.1261. Want to find dou b by dou k0. We are calculating b value. So that is, so b value is average of the all the elements, right? Average, that is 1 by 4 of minus 1 plus 1 plus 2 plus 5. We are calculating the average, that is here A00, A01, A010, A11, that is average of all the elements. The how A00, A01, A10, A11 depends on this K00 values. How these are depends on the K00. Forward passing, during the forward passing, how you are doing average pooling, that is the mean value of the, that is average means mean value, right? That is the mean value of the matrix A. So in opposite direction, in backward pass, we did this exact opposite. So mean means, generally mean means average we are taking, that is we are decreasing the value equally. Whereas in upward pass, that is in the back propagation, it takes the incoming gradient y hat by dou b, that is the incoming gradient. Dou b equally distributes this gradient, that is dou b by dou y hat. It equally distributes this gradient to all the elements, that is equal contribution. So equal contribution, that is one equal contribution of the average of this all the values. So we are taking average of all the values in the forward pass, whereas in the back propagation this gradient value is equally distributes to for all the values, equal contribution. So that is the derivative of the b, that is the gradient dou b with respect to dou A00, is 1 by 4. Same dou B by the equal contribution dou A01 is also 1 by 4, and dou B by dou A10 also 1 by 4. Dou B by dou A11 is also same value, that equals to all are equal. That is the derivative of the B with respect to individual elements, that is pooling. Pooling means individual elements, so that is pooling of the individual elements with respect to A00, A10, A11, A01, all are equal. That is the matrix A contributes, that is A0, we are differentiating with respect to A00, right? That is the contribution of the matrix A to the contribute to the matrix with to the final loss is equal. So that is average pooling in back propagation. So it divides the incoming gradient, that is incoming gradient is dou y hat by dou b. Incoming gradient that is dou y hat by dou b equally among all the elements, right? If the window size is 4, that is 4 elements are there, window size is 4, that is 4 elements, minus 1, 1, 2, 5. So it equally, window size is 2 cross 2 matrix, right? 4 elements. So that every elements get equal contribution, that is 1 by 4. 2 cross 2, 1, that is 1 by 2 cross 2, that is 1 by 4. 1 by 4 times dou A00 by dou K00 plus dou A01 divided by dou K00. So that is, we want only with respect to this element partial differentiation, that is the loss with respect to this element only. The contribution is same, 1 by 4. We already calculated, right? Here the window size, the contribution is 1 by 4, 2 cross 2 matrix. That is dou A10 by dou K00 plus dou A11 divided by dou K00. So every element K00 depends on this matrix A, right? So the general formula for this kernel depends on this matrix A is Aij is equals to sigma m equals to 0 to 2, that is n equal to 0 to 2. So we have values A00, A01, A10, A11, right? That is Aij. So I value is 0, j value also 0, I value is 1, j value 0, ij values. I value is 0, j value 1, both are 1. So that is x I plus m comma j plus n times k m n. This value is I, this value is j. So this value is I, this value is j. So I is 0. So that is I equals to 0 and j is 0 and j is 1, right? Here I value is 1 and j value is 0. So that is I equals to 1, j equals to 0 and j equals to 1, right? Want A00, that is I value is 0 and j value is 0. That is sigma m equals to 0 to 2 sigma n equals to 0 to 2 x I equal to 0, right? 0 plus m comma 0 plus n times k m n. But here we know k 0, right? K 0, 0. So m equals to n equals to both are 0. So in this value, that implies a 0, 0 equals to x 0, 0 times k 0, 0. That implies a 0, 0 by k 0, 0 equals to x 0, 0. Okay, x 0, 0. In the same way, this is the 1. In the same way, a 0, 1 by k 0, 0 equals to x I is 0. I is 0, j is 1. That is x is 0. So a 1, 0 by k 0, 0. Why only k 0, 0? In this question, they are asking find differentiation with respect to k 0, 0. That is dou L by dou k 0, 0. That is x 1, 0. And fourth one, a 1, 1 equal to k 1, 1. That is x 1, 1. So from the x represents the input matrix, right? So the input matrix. In the input matrix, we want x 0, 0, x 1, 1. So this is the input matrix x. We want x 0, 0, x 1, 1 and x 0, 1, x 1, 0. X 0, 1 and x 1, 0. This matrix, right? This 2 by 2 matrix means these values, these 4 values. That is 1, 0, 1, 2. 1, 0, 1, 2. Okay. So these matrix values are 1, 0, 1, 2. So this value is 2, this value is 1, 0 and this value is 1. Find dou b by dou k 0, 0. So dou b by dou k 0, 0. That is this formula, right? 1 by 4. That is 1 by 4 in this formula. 1 by 4 times dou a 0, 0 by dou k 0, 0 is this value 1 plus this value is 0 plus this value is 1 plus this value is this value 2. This value is 2, this value 1, 0 and this value is 1. So that's why 4 times 4 that equals to 1. So that is dou b by dou k 0 is 1. So generally without calculating all these things also we find. So equal contribution, its value is always 1. Its value is 1 plus 1. The answer for this question dou L by dou k 0, 0 is minus 0.126. They are asking 2 to 3 decimal places. So this is the answer, minus 0.126. Videos, please like and subscribe my channel. Thank you for watching.